Good afternoon, everybody. It is my proud privilege to be with you in Korea University, and I am very happy to share my knowledge with this research fraternity of Korea University. I must be thankful to the organizing committee for inviting me as an invited speaker in this session. And I am here due to Professor Jung and one of my students, Dr. Pala Shaman. So with these brief introductory words, I would like to give some concept that is called ecotoxicology along with the biomarkers. The ecotoxicology in this present status, shifting from the dilution paradigm. The dilution paradigm means which was initiated Second World War. At that time, dilution of the pollution is the solution. Then we shifted towards the boomerang concept. That means as and when you dump the waste, it will come back to you in your system, which was held in 1960s. After that, it was came into the environmental toxicology, which was extended up to ecotoxicology by the man who is called Truhat in the year 1977. Truhat is the first scientist, possibly. He defined the science, modern science of ecotoxicology. And it emphasized the individuals, populations, communities, and ecosystem along with its whole entities. Then, Newman, in the year 2010, he told about the synthetic science of toxicology that is called ecotoxicology. So presently what we have seen, the identification of the markers of long-term risks. Please note down this term, long-term risks. If we go back to the ancient era of toxicology, at that time, during 1497 to 1543, the father of toxicology, really the big name, because he is the father of toxicology, Philippus, Aurelius, Theophrastus, Bombastus, von Heinhem, Paracelsus. These are how do you imagine what is the big name of this? Paracelsus, he formulated the notion of dose-response relationship. Subsequently, the founder of toxicology, another big name, Joseph Matthew Bonaventura Orfila, during the year 1787 to 1853, he first told or framed the articulation between the effects that we call pathology and the content of the contaminant which is present in the system. So, the new system was developed that is called modern science of toxicology, which has become very essential in the ecosystem. In the ecosystem, first you have to take the note of it that the present contaminant undergoes these pathological lesions that you can identify through analysis, characterization of the chemical content by means of the analytical methods, and to explore the mechanism by means of which the toxicity can be maneuvered or the toxicity can be explained. But I want to say one thing very important for all of us, those who are studying the ecotoxicology, that is Rachel Carson, the lady Rachel Carson is the Silent Spring, the book Silent Spring. It is the landmark. It is the landmark of public awareness regarding human health as well as environmental health, which is caused by the man-made toxicity. So the present status, we explain you how it comes into the ecosystem through individuals. But ecotoxicology is facing the problem today due to only that it is important issue in that is the population stability. You know the gene pool, so the population stability is very important in this respect. Secondly, the identification of the positive agents. We cannot identify the one positive agent responsible for one effect. So there is a mixture of the different chemicals which is cumulative for getting the effects in the ecosystem as well as human health. As you know, the interaction between the chemical agents or the foreign bodies or so many xenobiotics is like that, which can be potentiation, additive, antagonistic and synergistic. So these four mechanisms by means of which the cumulative toxicity can be studied. So if it is sporadic in nature, then it's become very difficult to identify the toxic agent which become toxic in specific way. As a result of that, this specific agent for giving the specific biomarker becomes not so easy. So how does this toxicants come into this one? The ecotoxicological concept and the classical concept of toxicology is different. Ecotoxicological concept, it follows the four paths. The first one, it will enter into the medium. The second one, it will transport. The second one, it will transport. The third one, the animals or the plants or the organisms undergo exposure. How the time it is concerned, that is called exposure. And finally, it will show the symptoms, that is the effect. So whatever you are getting from the atmosphere or the terrestrial surface, if it comes into the water, then it will be transported to the different organ or organ system of the organism. If you consider the fish as an experimental aliquot, so it will uptake, then transport, then it will be distributed throughout the body, undergo absorption, and you will see the effect. The fate of the toxicant is very important in this regard as and when it will come into the water. The first one is dilution, because until and unless this concept you can remember, during Second World War, the dilution of pollution is the solution. So this dilution, then microbial and photodegradation, as we are in the tropical country, it is very much important for all of us that to know the photodegradation. That depends, obviously, depends on the chemicals. Then it is binding to the particulates and organic matter which is present in the water. This leads to the sedimentation, that is called precipitation, and it is undergoing bioaccumulation. As and when you will get the distribution of the toxic substance, it will be distributed all along the body. This is called accumulation in the different target organ. Now I come to this session which is called biomarkers, the importance of it. To whom we will call the biomarker? You see, to define the biomarkers, I have sufficiently long half-life. Everything cannot be used as a biomarker. Until and unless it will get the long half-life, it will be accumulated. That means it will come first, release, then transport, then distribution, and then effects. Second, which is very much another important, that will change the biological system. There are two types of biomarkers what we are dealing with right now. The one is classical biomarker, that is called in vivo, and another one is called in vitro. In vitro biomedical biomarkers, they are toxified. They are identified through the genotoxicity, estrogenicity, and different promoters that we are applicable. There are three distinguished biomarkers in this system that it is called exposure biomarker. As I told you earlier, that the number of chemicals which is present within the system, it will go for this exposure. Second one, the biomarker of effect, as I told you earlier, which is called pathological marker. And the last one is the markers of susceptibility. And these three markers are associated, how they are connected with each other. You see, from this phase 1, phase 2, phase 3, phase 4, and lastly the phase 5. In the phase 1, you are getting exposure and absorption. The second one, distribution and metabolism. When the toxic substance, suppose in the molecular state, we know the toxicology, one molecule type of theory. That means one molecule will hit one biological molecule to make the BT, that means biotoxicants. This is the metabolites that will produce the effect. So it will first show the subclinical changes. As and when it will be chronic, that means the duration will be longer, then you get these clinical symptoms. Over and above all these things, it is known as biomarkers of susceptibility. These are the different levels of marking the biological system and its biomarker. Starting from the molecular, you see this is the molecules, As you have seen, starting from these molecules, this may be the DNA. The enzyme system, it's may be cytochrome P450. It may be the pathways, suppose the synthesis pathways. Then the organelles. You see, when the endoplasmic reticulum undergo damage, the ALPS synthesis or ACPS synthesis will be less. So, if you corroborate this, one part of the transmission electron microscope where the endoplasmic reticulum is damaged, and the another part of this in the biochemical changes, so you can collaborate all these findings as a biomarker. Then you come to the cell, then tissue, organ, individual, population and community. And if I start from it, which is the most possible predicted biomolecules and the potent one that you get these molecules. But if you see the increasing number and the diversity, then you have to go to the community. Because I have started with this concept of ecotoxicology, that it is starting from individual to community. This the exposure biomarker that you will do. This is our area of study that we are doing here. It has become difficult to study. Only one reason behind it. We cannot tell you anything about whether or not the exposure cause and effect. Second, the effect can be misleading because there is no sensitive instrument which requires at the nano level or ppb level. Sometimes it happens you can show with the histological or topological structures. Then its second one is misleading, which is association or causes. These are the some specific markers. I will not tell you only the things. How could you measure the biomarkers? That is the test. That is called MN test, means micronucleus test. Within the nucleus, if there is a fragmented part of this nucleus, it will be present within the cell. That is called micronucleus. It is very much obtained in the erythrocyte of the fish. Because in the fish, that erythrocyte, that is the erythrocyte with nucleus. Okay? So these specific markers is need not, it can be alone to identify the monitoring system. Because they are specific in that sense, because biometric test or this can confirm you the test of a biomarker. And because it is highly specific. Suppose we are using the organophosphate of pesticides and we are using as a biomarker the ACH, that means acetylcholine esterase activity. So the inhibition of the acetylcholine esterase activity need not to be confirmed in any other means, but this means as a biotoxicity. These are some other markers like the morphometric study, which I will also show you a very quick slides, organoids, growth, etc. Histopathological, that is necrosis, apoptosis, inflammation. Some histochemical measurement also become very much identifiable today. That is the content of the polysaccharide which is excluded or released or excitosis from the mucous cell or epithelial cell. So if the quantity of the mucopolysaccharide and its qualification, either it is acid mucopolysaccharide or this is acid mucopolysaccharide or this mucopolysaccharide which is present within the mucus, you can identify this through the means. The biochemical, so many workers are there, they are doing this one biochemical, and the gene and chromosomal level, that's the micronucleus test which is conventional. Then the cancer level. If you consider this fish, we have taken these different organs, limit this. These are the histopathological markers. Histopathological markers are of two types. One is non-neoplastic, where you can get the accumulation of the phospholipids, inclusion of the fibrils, and the benign neoplastic, that is the some of the pancreatic acinar cells, that will show you how much it is benign. The malignant cell, it is also in the exocrine pancreatic cell, which is present in the fish, but particularly in the carnivorous fish. These are the different symptomatic histopathological changes which you can observe or detect as a biomarker. If you consider these are the control one and these are the primary gill lamellae, and you see there is a conglomeration of this those two, this one and this one, this one. So these identification being very particular definitely give you some concept regarding the biomarker, which you can observe through this. You see how this secondary gill lamellae become extended towards this one. So these are some definitions of this. This is a very rare picture I have published in my. This is the conglomeration of the chloride cells. You see. So these are identification of the. This one. This will give you the structure in the stomach, which is present in the fish. In the fish, the stomach has got a very peculiar character. From the columnar epithelial cells, immediately there is the gastric glands. In the gastric glands, it is secrete the gastric as well as the secretion of the mucopolysaccharide. So the number of changes which is occurred here, the number, this is control one and this is the treated one. Again, you see the changes in the mucosal fold will give you that is a very good indication of the stress condition, and through means of which you can monitor the toxicity or the toxic level of the fish. This is again in the intestine. This is histological sections. I will go to switch because this is some liver. In liver, that is hepatocytes, and the sinusoidal changes. That means the size, the cell. In between the cell, there is a gap which is called sinusoids. It is not the back end part of it, but it is made up of some cells. This is the pancreatic portion. You see, this is exocrine glands. This is some pictures I have taken from by courtesy, I would say, from Newman. The same thing which he has also shown. This is as a marker. You see, these are the nuclear proliferation and the syncytial mass within the cell. Same thing it is in. Now it is in kidney. In kidney there are two types of, at least one is proximal convoluted tubule where there is some absorption, and other two types of cells that is not absorptive in nature but they are collective. That is called DCT or collecting duct. This is proximal convoluted tubule. I will show you in the electron microscopic structure where you can see the absorptive nature of it. Okay, this is my bread. This is the bread cell. Here, these are some scanning electron micrographic presentation, which you can give it a very clear picture of this control one. This is the stratified epithelial cells. This is the stratified epithelial cells, and each stratified epithelial cells is made up of the concentric ring of microridges. And these microridges, the gap between the two microridges, there is a double ridge microridge structure. Within this double ridge microridge structure, you can get what is the indication behind it. So if you quantify the number of concentric ridges in the cells, then you can also mark it as a, because sometimes it happens that histologically quantification and qualification is not possible. But the quantification is possible if you mark it in this terminology. This is another good picture of it. See, this is stomach. In stomach, you see, these are the columnar epithelial cell. The columnar epithelial cell type in the stomach and the columnar epithelial cell type in the intestine is different. In the scanning electron micrograph, you can see these columnar epithelial cells with stubby microtubule. Okay? And the distortion, the number of distortions, suppose this is the square area of it, you can measure it. And this is the number of epithelial cells, microepithelial cells in the topology. They are going, they are damaging, they cost. It can also observe through this microscope in a higher magnification. This is the intestine. In the intestine, you see the microridges in the epithelial cell, the microridges are more because this is absorptive columnar epithelial cells. The transmission electron microscope of the gill, here the chloride cells will indicate the number of the presence of this nuclear structure, and you see these are the endoplasmic reticulum and the mitochondrial structure which undergo changes. That will give the concept, which is the number of enzymes. It is changed in the biochemical test. Again, this is the stomach. In the stomach, this part you can observe it. I hope this is the microcalyx, which is usually called glycocalyx. This glycocalyx and the appearance of this, you see endoplasmic reticulum structures. You see the nuclear deformities and the presence of huge number of glycogen droplets. In the intestine, as I told you earlier, These are the absorptive glycocalyx. So number of brass borders, these are the number of brass borders, and you change, observe the changes here. So that is an indication of this marker. Again in the liver cell, particularly in the liver cell, it is rich of the glycogen complex, rich in glycogen complex, and this is normal nucleus, but it is formed one, deformed one. This is the kidney cell. Again in the kidney cell, as I told you earlier, the proximal convoluted tubule, there are some glycocalyx because of this absorptive nature of the proximal convoluted tubule. This is, as I told you, the morphometric analysis. From morphometric analysis, you can also mark some of the indications, which is called as the gonadal somatic index, the hepatosomatic index. Some enzymatic markers, that is the catalase activity, and the glutathione transferase activity, that is ACTH activity, and lipid peroxidase activity. As I told you earlier, that from the biomarker analysis, you can go for the risk management. Risk management or risk asset management, whatever it is. It requires the 4 stages, the different stages of it. First of all, you have to measure the hazard identification. Hazard identification includes 2 parts. Dose response assessment. The dose response assessment is, as it is told by the Paracelsus, if you increase the dose, the toxicity will be different. If you increase the dose, the toxicity will be different. The same concentration is measured depending on the dose. So, dose in the ecosystem is very much important. Then exposure assessment. Exposure means whether it is 1 day, that is 24 hours, 5 hours, 10 hours, or even it is extended for 24 hours, 72 hours, 96 hours, or it can be 1 day, 24 days, or 7 days, 15 days, or month. So depending on the dose, the toxicity will be, that means receptor RT is proportionally equal of it. So from these stages of risk identification, you can measure the risk characterization, you can go for the risk characterization. Ultimately, you can go for risk management. I have described all these hazard identification part of it. Most important of it, all of us, we have to know that the NOEAL. NOEAL means the no dose. That means when you are taking the highest dose, the response measured is not significant. Again you see, LOEL, that means when you are taking the lowest dose, but it is response is significant. This type of measurement is okay. This is hazard characterization, this is exposure assessment, and this is my concluding thing for this way, that when we use properly the biomarkers, it is important tool for the determining, but we have to become very cautious about it before using it as a biomarker or using it as a biomarker. Thank you everybody for listening.
So, thank you for your interesting presentations. So I just wonder, for practical application of biomarkers to regulate like streams and contaminated waters.
Yes.
Yeah. So the quantification of biomarkers is quite important. So can you give us some ideas about that?
Regarding the quantification of biomarkers, the number of cells involved in the areas and the measurement of the type of necrosis which is present over the cell, this will give you the concept of the quantification of the biomarkers. If you consider the 10 or 100 cells in one area, and another slide if you consider the 50 or 100 cells in another area, then you measure the number of cells with the damage, with the number. Here also you can comment, suppose it is exposed with the organopesticides and it is exposed with the heavy metals. Then you can quantify both of them. How many cells are affected and what are the types of necrosis that you are observing. As it is shown in the transmission electron microscope as well as in the scanning electron microscope, you have seen the number of cells and their damages is not same. So if you are able to measure the number of cell damage with this part of it, we will give you the concept of quantification. And you can get it 1, 2, 3, 4 accordingly. Suppose there is 70 to 80% or 60 to 70% or 50 to 40% or less than 40%. So what are the number of this assessment is there? Accordingly, you can grade 1, grade 2, grade 3 or grade 4. So this will give you the quantification. We have published this paper in our Ratan very recently regarding quantification.
Thank you.
Okay, thank you.
Hi, thank you so much for the informative presentation. My name is Chung Kim. I'm currently majoring in urban regeneration. I've got a question that might sound somewhat premature, but can you actually identify the chronological features of intoxication from examining these biomarkers? If these kind of changes in cells permanent or just a very short term, does it cause is this kind of contamination permanent? Is it mutational throughout the generations? Can you actually evaluate these kind of stuff as well?
There is a very good test for it, which is called MT. That means metallothionein test. As and when you will apply the metallothioneins, which is present already in the liver, if you add the cadmium, you will be getting a chronological difference in the concentration of the metallothionein. So that will give you a very good idea how much or what is the total period of exposure of that element. Or if you go for the MN test, the number of nucleus, the micronucleus which is present within the cell, the amount of stressors as well as the exposure of the stressors, that will chronologically give you an idea about this concept. It is very easy to test what is the date of exposure, because as and when you are going for the wild collection, you don't know what are the concentration which is coming from the point or non-point sources. You do not know what are the type of contaminant which is present within this running water. So when you are getting this type of fish or experimental aliquot, what you have chosen, and you take the blood of this sample from hematological culture, you can identify the number of micronucleus tests, or from the liver, that is the MT test. This MT test and the micronucleus test will give you this chronological order of the number of days of exposure as well as the concentration of these chemicals. If the number of chemicals or the concentration of the chemicals that you can get through the AS analysis, atomic absorption analysis, spectrophotometric analysis.
Okay.
Thank you.
Thank you so much. What a great presentation.